7. Okay, do we start number 8? No, okay, all right, so let's go through number 8. Number 8 says, find the most general expression for the function if f double prime is equal to that polynomial that you see. So first things first is we know we got to go through our antiderivative twice. We're all the way down at the second derivative. We'll take the antiderivative once to move up to f prime. And then after we take care of that, then we'll take the antiderivative again to get from f prime to f of x. Okay. So to indicate that we are going to take the antiderivative, we'll go ahead and put integral notation around it to indicate to show what procedure we want to do. Allow that to happen. So we'll say f prime is equal to, and you're just going to put an integral notation around your f double prime expression, your original expression, so that we can basically give that note, provide what we want to do, right? After we make our problem go through this procedure, the results of this will turn it into f prime. Okay, so we haven't done the antiderivative yet, but we've placed it there to indicate what we want to do. So now we can go through power rule. Every term will go through our power rule. So 4x cubed becomes 4x to the 4th over 4. 5x squared becomes 5x cubed over 3. 3x becomes 3x squared over 2. 6 becomes 6x. And then we also need a plus what? C. Plus c. I'm going to stay at f prime for one more step. I'm going to just do a little bit of cleanup. The 4's canceled out, and I'm just pulling the coefficients out in front to get myself ready for my next antiderivative. Okay. So we're officially at the halfway point. It says find the most general expression. We're not able to solve for c because they don't give us enough information to solve for c. We'll leave that c alone, and it'll just stay with us as we take our next step. Everybody okay so far? Okay. So now we want to take the antiderivative again to make this turn into f of x. So again, I'm just going to put integral notation around my expression to show what I want to do. I haven't done it yet, but I know that after I complete this process, the result of this will be my final function, f of x. Every term is ready for power rule, so we go through power rule again. X to the 4th becomes x to the 5th over 5. 5/3 will just hang out in front. X cubed becomes x to the 4th over 4. 3/2 hangs out in front, x cubed over 3. 6x becomes 6x squared over 2. What do you think is going to happen with the c here? Imagine that c is like a 5 or 6 or 8. What would happen to that c, you think? Cx, good. So the constant, c is a constant, so it's going to rise up to degree 1. So it'll be Cx. But this is also going to produce its own what after the Cx? Another plus c. Good. So I typically indicate that with a different letter, or you can call it c sub 2. K is like a common letter that is that's used. So you can use plus c sub 2. You can say plus k. But yes, here we have our general equation. We're not able to solve for c or solve for k because they don't give us enough information. So we just have to hold on to it. And that's why we're able to call this general expression, because we don't have a very specific value to plug in. There is a family of functions that we can plug in and all fulfill the fact, any number that I plug in for c or for k will produce a second derivative of this, right? Because all these numbers will drop out. So it doesn't matter what these numbers are. All these potential functions will all share the same second derivative. Number 9, same process as number 8. It's just that we're going to be able to solve for our C or solve for our K based off the order pair given to us. So go ahead and try number 9. You're going to set number 9 exactly the same way. So find f of x. You know f of x is the integral of your g of x expression. After you find f of x, well, 3x squared becomes 3x cubed over 3, 4x becomes 4x squared over 2 plus c. So we're now, we only have to take the antiderivative once. We're just going from f prime to f of x, or f prime to f of x. But we can resolve that plus c, solve for c, because we have order pair at the function level. So plug -1 in for x, plug 2 in for y, solve for c. And once you solve for c, then you can go back to your general equation and replace the c with the number that you found. So 2 equals -1 minus 2 plus c. C equals 5. So now we go back to our function, update our c to equal to 5. If we leave it as plus c, that would be called a general expression. If we update the c to a 5, we call that a specific solution or specific expression for f of x. All right, let's go to page 39. All right, go ahead and start I walked through each of the problems with you from worksheet one. So hopefully you guys can take that and try the first steps on your own for worksheet two. And I'll still go through each of the steps with you, but I want to see if you guys can start each of the problems on your own. All right, so number one, you're plugging in 2 into the expression, then you plug in 3, then you plug in 4, add up all those individual expressions, see if you got 1535. Okay, number two, we have to get all this into a rule. So I want to find a rule that will allow the first term, when you plug in I equals 1 to get that first term. When you plug I equals 2, you get that second term. I equals 3 will give you that third term, and I equals 4 will give you that fourth term. Fill out the parts that is unchanging. And then you can just focus on kind of playing with different patterns. Maybe it's something involving multiplication with a number. Maybe it's something involving squaring of I or cubing of I or 3 raised to I or 2 raised to I. So it's a little bit of kind of trial and error. You know, as you make your guess, you want to go back and try your rule to see if it will produce the terms that you want it to produce. So what can we place inside the square root so that if I plug 1 in, I'll get 2. If I plug 2 in, I'll get 4. If I plug 3 in, I'll get 6. What do you think? 2 times I, okay. And then we also want to create a different rule where 1 will give us 1, 2 will give us 4, 3 will give us 9, and 4 will give us 16. Squared, yeah. And we just double check that, right? Plug 1 in, we get 2 and 1. Plug 2 in, I get 4 and 4. Plug 3 in, I get 6 and 9. 4, I get 8 and 16. Yeah. Okay. Number 3, use 3 left-handed rectangles. So you want to first start off by building your width. And then you're going to create sort of like your x-axis number line. Find each of your subintervals by adding your width from your left endpoint to your right endpoint. And identify the width and identify how you want to find the height for each of your subintervals. My A value is 3. My B value is 7. My N value is 3. So B minus A over N, 7 minus 3 is 4. 4/3 is my width. So I need every rectangle to have a width of 4/3. I'm going to start at my left endpoint, which is 3. I'm going to add 4/3 to 3. 3 plus 4/3 is 13/3. Plus 4/3 is 17/3. Plus 4/3 is 21/3, which is 7. If we're asked to find midpoint, then you have to do a further process of finding the average of these two numbers, finding the actual midpoint before plugging in and finding the heights. But if it's a left or right-handed rectangle, we can stop here and just start gathering, attaching the left endpoint to the curve to get the heights. And then once you set up your function notation, so that represents the width and height, and the rest just plugs into your calculator, into the function to get those physical heights that you can use to approximate your area. Number 4, you have a table of values, so you're going to go ahead and find the width and the height from each of the intervals. Remember, if you're given the table of values, we never want to use this. Okay, I see a lot of students try to force the b minus a over n into a table of values. So you should be able to grab all your width and height from the table. So use the width defined by the table. You're not going to create your own width. And you're subtracting numbers from your first row to get your width. Then the height, you're just pulling the numbers that you see from the second row. Any questions with part A? Okay, part B, left-handed rectangles. Part C, trapezoids, you're grabbing the width the same way as rectangles. The formula is a little bit different. 1/2 times width times height 1 plus height 2. Careful though that we only are using 2 height values for every trapezoid. You may be tempted to think that, oh, I got to add the 8, the 3, and the 1 together. It's only the 8 and the 1 because those are the endpoints of our interval. So we're only using 2 height y values for each trapezoid area. Everybody okay with table of values? All right, so 5 is the limit definition of area. Okay, start off by building your width. So we're using the formula, limit definition that you can find on page 34. So we're going to replace width with 3 over n, replace the a with -2. Any questions so far? Right, next step, we want to get this out of function notation. So all this is going to go in place of the x of my function. So my function is 3 plus 2x squared, and I'm just replacing the x with my entire argument. Now that we're here, we can just focus our attention on what we see in front of us. We're going to expand, FOIL, distribute the 2 through, combine like terms. Then we can involve the width, distribute the 3 over n through. And then once every term is nicely separated, we can decide which summation rule that we want to apply for each term. And then once everything is in terms of n, then we do limit as n approaches infinity and just pull out the coefficients from each of our fractions and then add them together. All right, go through your algebraic steps. Now, once we have each of our terms nicely separated, we can involve summation for each of our terms. So there's a summation 1 that we have to resolve, summation I to resolve, summation I squared. Each of them will be replaced in terms of n. And then within each fraction, we're just trying to find a matching pair of degrees so that we can hold, or matching pair of highest degrees, So we can pull the coefficients, fractional coefficients out, so we can add those numbers together, and that will lead us to our area. Okay, page 40. All these problems are largely power rule, except for 6. 6 has a combination of trig and power rule. But I want to focus on number 8 here. So if we can let 8 be the last one that we do in class together. So number 8. I worked it out differently on the key. So I prefer you guys to work it out the way that I'm going to do it here by splitting up into individual fractions so that you can remind yourself that every term is going to have to deal with that x. And the direction here is just to find the antiderivative of that function. I'm going to go ahead and start cleaning up and splitting up into individual fractions. And then I have to resolve each of my denominators before I can do power rule. This is how my first step would look. The way we merge the x's together is by subtracting exponents. Remember, we can't do power rule unless all the variables can find a way to bring up to the top. Notice that I'm holding on to my integral notation because I'm not ready for power rule, right? So all this cleanup process is pre-calculus. So we have to hold on to all those integral and dx notation until we're ready for power rule. Once we apply power rule, where we add 1 to the exponent divided by that new exponent, then we can drop those bookend notations. So these are all denominator has all they all have exponents of 1. So 3 minus 1 is 2. 1/2 minus 1 is negative 1/2. 1/4 minus 1, same thing as 1/4 minus 4/4 will be negative 3/4. Now every term is ready for power rule. Our next step can be power rule. And after we apply our next step, we can drop those notations in front. Okay, so your homework, don't follow the calendar here. For your homework, I just want you to finish up worksheets 1 and 2. So we did page 37 and 38. Today we did page 39 and part of page 40. So really just finish up page 40. I'll just check those 4 pages for homework tomorrow. Now tomorrow, we need to start our next unit. So, or sorry, our next section. Obviously, next section is not going to be on the quiz. And then we use maybe the last 15, 20 minutes just to continue to do some more practice. I have your quiz is on Friday. I have 2 help sessions coming up tomorrow morning at 7:30, and then Friday morning at 7:15. 7:15, I'll work through worksheet 3. Friday, I'll work through worksheet 3 in your packet. All right, come get your phones.